take a look at negative exponents. So here's the deal with negative exponents. Sometimes having your simplified answer with a negative exponent is acceptable. Usually, you're told, write your answer with negative exponents or something. The only thing is, most of the time, it is not acceptable to have a negative number as an exponent. It's kind of like you wouldn't answer 3 over 1. That's not simplified. 3 is simplified. 1x is not simplified. X is simplified. So a negative exponent means you're not finished yet. Now, we did look at a pattern, but the pattern started getting a little bit confusing in a sense that 1 divided by 4, once we got the pattern that we had on the 0 exponents, once people got here, they started getting a little mixed up. Okay, if you did 1 divided by 4, you may have gotten 0.25 if you used a calculator. You could have also written the division problem as a fraction and got 1/4. Which was fine until you got to the next part where you had to divide 4 again. And it really wasn't bad, but it could have gotten a little bit tricky. So let's approach this a little bit differently. We're going to simplify this expression 2 ways, just like we did before. Let's simplify with the quotient rule. So that means if I'm dividing with the same base, I keep the base and I subtract my exponents. Now be careful with your subtraction because it's when we're starting to get some negatives. If you have to, add the opposite, and you end up with 2 to the negative 2nd power. And I just said a negative exponent is not an acceptable simplified answer. But for this, what we're looking at here, keep it this way for just a second. Now let's simplify without the rule, which means I'm going to expand to a repeated multiplication problem. So let's cancel, cancel, cancel. And I'm going to rewrite this with a power in the bottom. I'm not going to multiply and get 4. I'm going to write 2 to the 2nd power. Now again, I have the same expression on both sides, but I got what appears to be 2 different answers. But because I started with the same expression and everything's mathematically correct, I could say 2 to the negative 2nd power equals 1 over 2 to the 2nd power. Just because of math. The same expression equals what looks like 2 different things, but actually they're equivalent. Let's look at one more. We have x to the 2nd power over x to the 7th. So let's simplify with the quotient rule. Same base I'm dividing, keep the base, subtract the exponents. Add the opposite if you need to, and you get x to the negative 5th power. On the right, we'll expand this out. Cancel, cancel. Now, when everything cancels on top, that doesn't mean there's nothing left. Okay, these become 1s. right? A number divided by itself equals 1. So I have a 1 left on top. Okay, I didn't really talk about that on the last one. I'm left with a 1 because these x's turn into 1s. So I'm left with 1 over x to the 5th power. So again, by default, my left side has to equal my right side because x squared over x to the 7th equals x squared over x to the 7th. So I could say that x to the negative 5th power equals 1 over x to the 5th. So if we look at this again, we had 2 to the negative 2nd power equaled 1 over 2 to the positive 2nd power. I had x to the negative 5th equals 1 over x to the positive 5th. Do you notice anything that continues to happen? Does my base number change? No, my bases don't change at all. My base was a 2 and it's still a 2. My base was an x and it's still an x. My exponent does change though. My exponent on the top number goes from negative 2 to positive 2. Exponent down below goes from negative 5 to positive 5. So that becomes the opposite. Oops. Now there's a fraction situation here. I'm going to make one little adjustment. I'm going to put my original number over 1. That's interesting. The power that had the negative was in the numerator and then it ends up in the denominator. Same thing on the other one. So what's happening here is for my exponent to change from negative to positive, my power had to change from the numerator to the denominator. And that's where we get our rule from. Our first rule when we deal with negatives. Let's take a look at the first situation. This first situation is actually what we have, or what we had on that last screen. 2 to the negative 2nd power, x to the negative 5th. There's a power with a negative exponent in the numerator. So if you have a negative exponent in the numerator, what do? Well, you keep the base. The exponent becomes positive. The power moves to the denominator. So it changes places. It goes from the numerator to the denominator. So let's look at an example. A to the negative 3rd power. Okay. This power is in the numerator because if I forced a fraction, there's my numerator. So we keep the base. So the A is going to stay in A. The exponent becomes positive. So I'll have A to the 3rd power. The power moves to the denominator. So it goes from the numerator to the denominator. Negative becomes positive. Remember, it's 2 changes. I can't just make a negative exponent become positive. If I do a big change like that, I've got to do another big change. It's that one action causes a reaction. Now, the question is, what number goes in the numerator? According to those examples, it's been a 1, but let's see why. If I were to force a fraction and I were to put, a coefficient of 1, this power is the problem. So that power goes to the denominator. That leaves me with a 1 here, and that's my numerator. You only move the part of the expression that has the negative power or the negative exponent. Here's another example. 4 to the negative 5th power. Base stays the same, exponent becomes positive, and it moves from the numerator to the denominator. My numerator becomes a 1 because if I were to force a multiplication problem, I get 1 times 4, right, to the negative 5th. This is the problem. That moves, and I'm left with my 1. Here's another situation where you may see some negative exponents. There's a power with a negative exponent in the denominator. Nothing really changes except one part, which will make sense when you see it. So the base stays the same. Exponent becomes positive. And the power moves from the denominator. Actually, let's do this. Power moves to the numerator. So if the power was in the denominator, now it goes to the numerator. So it's like it switches places, like musical powers. Here's what I mean. So if you end up with 1 over 3 to the negative 5th power, I have a negative exponent, which is a problem. Can't have negatives in our answer. So we know that my base will stay a 3. Negative 5 becomes positive 5. Now to make that negative 5 a positive 5, I have to take my power and move it from the denominator to the numerator. It's like it's in the opposite position, and the exponent becomes the opposite. Let's look at one with a variable. So negative 7 has to become positive 7. X stays X. So in order to make my negative 7 positive, I have to take my power from the denominator and move it up to the numerator. Now, technically, we don't put answers over 1. It's not necessary. It's not simplified if you have a denominator of 1. So we can get rid of those. And actually, this would be positive 7. So again, the positioning becomes the opposite so that the exponent can become the opposite. That's like to balance everything out. I can't just start changing exponents without changing something else. Here's the very last thing you need to know. Only the power with the negative exponent moves. So here's what you do. Keep all parts of the expression the way they are. Only move power with a negative exponent. And we'll take a look at an example. When you would see this would be something like this. 2 times x to the negative fourth power. Let me move the 4 over. So here's the thing. 2 is not to the negative fourth power. The only way the 2 would be to the negative fourth power is if you saw parentheses like this. And we don't have those. The x is to the negative fourth power. This is the problem. So this 2 in the numerator stays in the numerator. It does not move. X to the negative fourth is the issue. I need that to be x to the positive fourth. So for me to make this x to the positive fourth, I have to move it from the numerator to the denominator. Another example. Y to the third power over x to the negative fifth power. First thing, I know I have division with powers, but I don't have the same base, so I can't use one of my rules. But I can tell that I have a negative exponent that's a problem. Y to the third power, there's nothing wrong with it, so I don't move it, I don't change it, I don't do anything. That stays y to the third up in the numerator. X to the negative fifth is no good. I need to make that x to the positive fifth. To make that x to the positive fifth, I have to move it from the denominator up to the numerator. And that's it. So one thing that can help you kind of separate everything and stay focused is do what I just did. Circle where the problem's at so that you can keep the things that are okay the way they are. And that's it.